Hello everyone, very good morning to all. Today we are going to discuss the core concepts of design and analysis of algorithms. Algorithm design is one of the core practical technologies of computer science. So in this lecture we are going to learn the core concepts of design and analysis of algorithms. So this course is particularly focusing on how to design the algorithms and then anal- analyze the performance of the algorithms with respect to time and space complexities. Whatever the problem we are having, that problem need to be solved. So the problem, producing the problem solution is a step-by-step process. So usually this step-by-step process is called as a algorithm. Originally, the algorithm word comes from the name of the Persian mathematician called Abu Jafar Muhammad. And to define any algorithm, so we said that algorithm is a step-by-step process, but every step-by-step process is not called as an algorithm. Every algorithm should have specific properties, like it should have a sequence of instructions such that every sequence is have a connectivity, and whatever the sequence we are having, the sequence should be finite. Means after finite number of steps, the sequence of steps need to be exited, and whatever the instructions we are specifying, these instructions must be unambiguous. Means that there is no ambiguity in the instructions we are giving. For example, there is a statement called add 5 or 6 to x. In this particular statement, we do not have any clarity that whether we should add 5 or 6 to x. So such type of ambiguity should not be there in the algorithm instructions. And to the algorithm, we should give at least 0 or more inputs. And these 0 or more inputs are very valid in nature. Why I am saying it is 0 or more inputs, sometimes the input can be specified as an implicit input. It need not be supplied as an external input. And whatever the instructions, the sequence of instructions we are having, these instructions must perform certain processing so that the given input can be transformed into a valid output. And after producing these outputs, every algorithm should be terminated after finite number of steps. So the algorithm can be called, a sequence of steps are called as an algorithm, provided whenever we are having 0 or more inputs and 1 or more outputs, whenever the instructions are finite in nature and instructions are unambiguous in nature, and also the instructions are effective in nature. This is called algorithm. And to express the algorithms, we are using a representation which is called as a pseudocode. And the basic operations, to write any program, we require the primitive operations, conditional operations, and some looping operations. All these operations need to be represented in terms of the pseudocode. That's all for today, and in the next class we will continue with performance analysis.